Pluto. A potential collision course with Neptune. Pluto is a distant and confounding minor planet, once considered a part of our planetary family. However, recent alarming announcements by Neil deGrasse Tyson, a leading astrophysicist, and Michio Kaku have brought Pluto back into the spotlight with an incredible revelation. They suggest that this chilly world is on a collision course with Neptune. Yet how could this happen? And what might transpire as a result of such a significant event? Are we witnessing an intriguing cosmic eccentricity? Or is there an additional factor in this approaching, potentially cataclysmic impact? Join us as we examine the potential outcomes of a collision between Pluto and Neptune. The former planet, now classified as a dwarf planet, remains an enigma due to its odd orbit and continues to be a subject of interest in the astronomical community. As indicated by recent expectations from experts, Pluto's trajectory is dangerously close. Neil deGrasse Tyson and Michio Kaku are both raising the alarm about a possible dangerous collision between these two bodies, an event that might pose a critical risk to Earth. How is such an event even possible? Pluto's journey around the Sun is unlike that of any other planet in our solar system. It takes an incredible 248 years to complete a single orbit, meaning that since its discovery in 1930, it hasn't even completed one full revolution yet. However, the interest doesn't stop there. Pluto's orbit is marked by its astonishingly curved shape, which deviates entirely from the nearly circular orbits of the major planets. What makes Pluto's orbit even more astonishing is its 17-degree inclination relative to the ecliptic plane. The slope of Pluto's path is much steeper compared to that of other planets. One of the most interesting aspects of Pluto's orbit is its crossing point with Neptune's. For about 20 years in each orbit, Pluto actually gets closer to the Sun than Neptune does, challenging what we'd expect from their positions in the solar system. This raises a logical question. Why hasn't Pluto collided with Neptune? The answer lies in the gravitational effects of other planets. Shortly after Pluto's discovery, astronomers began investigating its orbit. Unlike the orbits of other planets, typically located close to the ecliptic plane, Pluto's orbit stood out with its steep inclination and curved form. The mystery intensified with the realization that Pluto's orbit indeed crosses Neptune's. Yet the stability of Pluto's orbit amidst these complexities is proof of the intricacies of celestial mechanics. The three-body problem in space concerns how celestial bodies, like Pluto and Neptune, move and influence one another via gravity. In fact, Pluto's orbit is turbulent. Minor deviations in initial conditions can lead to substantial differences over millions of years. However, Pluto's unusual orbital characteristics have been discovered to preserve long-term stability. Recent simulations have helped us understand how giant planets like Neptune, Jupiter, and Saturn influence Pluto's path around the Sun. Jupiter's massive gravity, in particular, is strong enough to keep Pluto on a relatively stable path, possibly for billions of years. These forces are essential in maintaining the order and consistency of celestial dynamics. Without them, our local planetary system would be a place of much greater unrest and unpredictability. Pluto's orbit is a remarkable illustration of celestial mechanics at play, displaying both stability and chaos within our solar system. The unique characteristics of its orbit, especially its gravitational relationship with Neptune, highlight the intricate and dynamic nature of space. Predicting major events, particularly those involving turbulent orbits like Pluto's, presents tremendous challenges. The inherent erratic nature of such systems means long-term forecasts are often filled with uncertainty. While computer simulations offer powerful tools for understanding and predicting future behavior of celestial bodies, they also emphasize the limitations of our predictive abilities. So, why are prominent astrophysicists only now raising concerns about a potential crash between Pluto and Neptune? Despite the complex forces working to prevent such an outcome, Neil deGrasse Tyson and Michio Kaku, two astronomical luminaries, have expressed concern. If Pluto and Neptune were to collide, it would be a powerful and captivating event in our neighborhood planetary system. the impact would release an immense amount of energy, likely breaking Pluto apart, given its smaller size and icy composition. Debris from the collision could scatter across the solar system, potentially threatening the moons of other planets. For Neptune, such a collision could alter its current configuration, or even its orbit, depending on the specifics of the impact. Michio Kaku, a prominent theoretical physicist known for his work in string theory, brings a unique perspective to the discussion. His views on space exploration and the connection between celestial mechanics and theoretical physics offer valuable insights into major astronomical phenomena like Pluto's orbit. Understanding the complex gravitational interactions and orbital elements of Pluto and other celestial bodies can produce essential insights for future space missions. This knowledge can help in navigating the planets more efficiently, predicting potential hazards, and even planning missions to the outer reaches of our solar system and beyond. The lessons learned from studying Pluto's orbit can be applied to exploring other celestial bodies, providing a roadmap for how we might approach and understand far-off worlds. In the realm of planetary physics, celestial mechanics and theoretical physics are deeply intertwined. The gravitational dance between Neptune and Pluto illustrates fundamental principles of physics. If Pluto and Neptune were ever to meet in the middle, it would be a significant astronomical event, offering a rare observational opportunity that might even intersect with string theory. This theoretical framework, in which point-like particles are replaced by one-dimensional strings, aims to explain the primary forces and matter in the universe. Such a collision could create extreme conditions of energy and gravity, potentially aligning with predictions made by string theory. For example, the high-energy impact could shed light on the behavior of fundamental forces and particles under extreme conditions, a key area of interest in the theory. While the direct effect on Earth would likely be negligible due to our distance from the outer solar system, the scientific implications would be profound. The repercussions of such an event might be profoundly capable of enhancing our comprehension of the fundamental nature of the universe, as described by string theory and other areas of theoretical physics. Pluto's confounding dance around the Wadom Sun's enchantment continues, providing scientists and enthusiasts alike with insights into the complexities of the universe's mechanics. Its becoming a dwarf planet again sparked discussion and redefined our understanding of planetary bodies. Recent discoveries about its orbit have reignited interest in its role within the local planetary system. Neil deGrasse Tyson and Michio Kaku are two notable astronomers who have voiced their concerns about a potential collision between Pluto and Neptune, illuminating the complex dynamics at play in our cosmic neighborhood. Their warnings emphasize the significance of comprehending the gravitational interactions and orbital mechanisms governing the movements of celestial bodies. Pluto's orbit, characterized by its unpredictability and steep inclination, defies conventional assumptions and challenges our view of planetary motion. Unlike the nearly circular orbits of its neighboring planets, Pluto's path follows a unique course, intersecting with Neptune's orbit at various points during its extended trip around the Sun. The gravitational influence of other planets, particularly Neptune, plays a crucial role in shaping Pluto's orbit and maintaining its stability over centuries. Despite its turbulent nature, numerical simulations of Pluto's path and theoretical models play a vital role in predicting the future behavior of celestial bodies and understanding the complex interactions between planets. These simulations demonstrate that, even over thousands of years, Pluto's orbit remains relatively stable within the larger context of the solar system's gravitational field. The potential for a collision between Neptune and Pluto, as suggested by astrophysicists Neil deGrasse Tyson and Michio Kaku, draws attention to the ongoing complexities and ambiguities in planetary dynamics. While such an event remains speculative and extremely unlikely in the near term, the gravitational dance between Pluto and Neptune underscores the fragile balance of forces that govern celestial bodies within our solar system. Beyond its scientific importance, the study of Pluto provides useful insights for the future of space exploration missions. The New Horizons spacecraft, launched by NASA in 2006, provided outstanding data and images of Pluto and its moons at the time of its historic flyby in 2015. The mission revealed stunning details of Pluto's surface, Features like water-covered mountains, ice, and vast fields of frozen nitrogen, enhancing our understanding of the geological processes shaping the distant dwarf planet. The success of the New Horizons mission highlighted the technological progress and collaborative efforts required for deep space exploration. Through the study of Pluto and its moons, scientists gained valuable insights into the diversity of celestial bodies and the environmental conditions present in the outer regions of the solar system. These discoveries have ramifications for upcoming missions to investigate additional dwarf planets and trans-Neptunian objects, furthering our comprehension of planetary formation and evolution. Pluto's status as a dwarf planet has also sparked discussions about the classification criteria of celestial bodies within the solar system. The debate over planetary classification reflects broader questions about scientific systems and the evolving nature of astronomical knowledge. While Pluto meets some criteria for planetary status, such as orbiting the Sun and having sufficient mass for self-gravity, its classification as a dwarf planet highlights the diversity of celestial bodies beyond the traditional 8 planets. Pluto's orbit expands our knowledge of celestial mechanics and planetary dynamics in the farthest reaches of the solar system. By examining interactions between Pluto, Neptune, and other celestial bodies, scientists can gain deeper insights into the formation and evolution of planetary systems. These insights are crucial for developing theories about how our solar system came to be, as well as for understanding the processes that shape planetary bodies over billions of years. Pluto's discovery and the results of subsequent research have improved our understanding of planetary migration and the formation of the Kuiper Belt, a region beyond Neptune populated by small icy objects. Organizations investigating Pluto's orbit continue to uncover clues about the gravitational interactions that may have influenced the formation of planets during the early stages of the solar system. Neptune's gravitational influence on Pluto's orbit provides a compelling illustration of how interactions between different planets can shape the trajectories of smaller bodies over time. Future research on Pluto's orbit and the potential for a collision with Neptune could help refine our comprehension of planetary dynamics and improve predictions about the behavior of celestial bodies. As we continue delving into the mysteries of Pluto and the outer reaches of the solar system, we may uncover new insights into the fundamental forces that govern our universe. A collision between Pluto and Neptune, though unlikely, would be a monumental event with the potential to provide invaluable opportunities for scientific discovery. Whether or not it ever happens, the investigation of Pluto's orbit and its relationship with Neptune will continue to inspire astronomers and physicists as they strive to uncover the mysteries of our cosmic neighborhood.